So you know how it is. You're going about your daily business, all is well, and then someone just comes out with a question, a maths question for you out of the blue, and it's on implicit differentiation. And you're like, whoa, I haven't actually done that for a number of years. Let's not go into how many and show my age. So I tried my hardest, and I thought it's something to do with the chain rule, and I managed to get a little bit of it right, but it was unfortunately hideously wrong in one aspect. So let's have a look at what I should have done. So here's the equation I was given. 0 equals xy plus y squared plus x squared. Although this was just given as an example, the person was asking how to actually do implicit differentiation and just gave me this as an example. And I haven't done this for many years, so I was trying to wrestle my memory back into action. And we decided it was all to do with the chain rule. So we got this bit right. Y squared, you do a chain rule. So you just treat it as differentiate, like it was x squared. You just times the front by the power, reduce the power by 1, and then you multiply by the differential of the y itself. So we got that 2y and then dy by dx. And then things with just x in just differentiate like normal, you just get the 2x, fine. What we went wrong with is what do you do when there's an x and a y? And somewhat foolishly, we just differentiate, well, I just differentiated the x to get 1 and differentiated the y to get dy by dx, and of course it doesn't work. And how did we know that I was wrong? Well, I got Wolfram Alpha up on my phone and I've printed out what it said for you, typed in the equation, and it helpfully told me that I was missing this plus y. I pretty much had everything else. I have the minus 2x, I have the and that 1 should have been an x as well. So I was missing that x and that y. So where should they have come from? Well, of course, you've all spotted it already. I'm sure it is this thing here that we made a mistake on, because I didn't do the product rule as well. Okay, so I just differentiate both of these. Obviously, you don't do that. When you've got two functions multiplied together, you've got to do the product rule. You've got to differentiate the first thing and leave the second one unaffected, and then differentiate the second thing, leaving the first thing unaffected. So if I now correct my foolish mistake, we should differentiate this to get 0 is. So we differentiate the x and get 1 and leave the y, and then we leave the x and differentiate the y, and then the rest of it was okay, so we get 2y dy by dx, and then differentiating that's perfectly fine, we just get the 2x as normal. And now when I rearrange this, there's the x that I was missing and there's the y that I was missing, basically. I'm going to get 0 equals x plus 2y dy by dx plus y plus 2x, and then I get dy by dx is minus 2x plus y. I've just swapped those around and I'm implying brackets because they're going in a fraction, and so yes, this minus is for the whole fraction, not just for that, and then I'm just dividing by this x plus 2y, and then I get the same as Wolfram Alpha. So the moral of the story is, if you're about to do your C4 exam and you've got an implicit differentiation question, then don't forget it's the chain rule for any y's that are in functions. And if you've got x's and y's mixed together, then it is the product rule for the bit of x and the bit of y combined, and then you just differentiate like normal. And if you're doing your revision and you're not sure if you've got it right, then type it into Wolfram Alpha and they'll tell you what the differentiations are. Just make sure you look at the right one. Obviously, they give me 2 because this is differentiating with respect to y, which I'm not doing. I'm differentiating with respect to x. So just make sure you read the right one on Wolfram Alpha. If you are about to do C4, well, good luck with your revision, good luck with the exam, and ta-ra for now.